of solar PV power plant design, energy yield analysis, solar PV system performance evaluation, solar PV plant lightning protection, techno-economic of solar PV power plant, and solar training in Asia Pacific region. He has amassed over 3 gigawatt of PV power plant system design engineering works in Asia Pacific countries. Without further ado, I will hand over to our speaker for today, Mr. Tan Ji-hua.
Right, thank you to everyone. Hopefully everybody can hear it.
Yep, beautiful.
Okay, I would like to share the screen. Okay, before I start, I would like to introduce myself. My name is Tan Ji-hua. I'm currently attached with the AFRY, Malaysia Tanjung Berhad. Actually, AFRY is a new company that is combined with the OF and the FORI, and we are the one of the biggest Nordics. We have a 5D industrial digital process and consulting, and as I say, there's a global Southeast Asia. In my company experience, we have a lot of experience in not only in global, we also have experience in Malaysia, such like in OE, honors engineering design review, vendors technical advisor, and also a technical advisor, and together with the independent engineers. So this is one of the product reference in Dubai, and you can see that my company also have a pump storage experience in this region also. And we also done waste to energy for the cogen. Okay, today's my topic is talking about the SWOT analysis of the ground mounted versus the floating solar power plant in Malaysia. As we know, Malaysia, we have currently tender the government or the energy commission, Suruhanjaya Tenaga, currently is a the bidding solar biddings tender to the market. So the target is 1 gigawatt. So a lot of people is looking at opportunities, see whether in floating solar or land-based solar. Okay, this is one of the good opportunity to for the Malaysia to expand the solar business or renewable energy business, you know, in this couple of years. Okay, and what is the floating solar opportunity and the land based? As we know, Malaysia, we have a lot of hydropower plant. We have a water dam which is consumed by the public. We have also a lake, and besides this floating solar, we also have a lot of land. But whether the land and the lake is suitable to be used, this is a very big chapter, because according my experience, there is a lot of the bidders or clients is asking whether the floating solar or the land-based solar is suitable in Malaysia or not. Okay, today we are going to discuss about how the opportunity of the floating solar and the land-based solar. Okay, as we know, the floating solar, hello. Hello, can you hear me? Okay, let me continue. Especially for land floating solar, okay, we have a lot of lands, agriculture, industrial, and residential. And the floating solar, normally, like, we need to select the good water body, you know, and also where is the lake or the dam which is not fully utilized by the public. And if let's say we compare to the land, we need ample a bigger size land or largest land to put up the largest system, especially like 100 megawatt or 130 megawatts. So as we know, the land is very costly compared to the floating, because lake there is no much of the price reference, okay, compared to the land. And if compared to the floating solar, the mounting structure support, okay, floating solar is a required floater, which is very costly, and there is not much of the supplier in the global compared to the land base, because in Malaysia, or even though it's in Thailand or in China, we have a lot of structure supplier. How about the safety? In terms of the safety, land based, there is a lot of compliant by the already set up by the ISO and IEEE and local standard. Compared to the floating solar, there is a lot of question marks about the floater, because the floater liability or the lifespan is still less than 20 years. But your PPA is take about 25 years or 21 years to 25 years. So the floater's liability is a big challenge in the current market. And the environment impact, the land base is not much of the environment, not much involved to the environment compared to the floating solar. Okay, for the floating solar, there is a lot of let's say require to comply the EIA, which is already set up by each country if compared to the land. Then for the local regulation and the permit, which is require a lot of authority approval, especially for the dam and also the hydro power plant if compared to the land. For the electrical cable and for the floating solar is much more higher and very costly, because you need a marine cable compared to the land-based solar. In terms of the technical, floating solar is harder compared to the land-based. Okay, how about the site selection? The site selection, ground mounted is, of course, the criteria we need to know the location have enough of the solar resources, available land, local climate, topography, land use, local regulation, land use policy or zoning, environment designation, geotechnical condition, political risk, accessibility, grid connections, module, soiling, water availability, and the financial incentive. As you can see from the photo, in Malaysia, we also have a flat land, but we also have the highest angle of the land. As you can see the bottom, there is a multi angle of the land because the developer have a limit of the flat land. So this is a lot of civil job we're going to impose. Compared to the floating solar, of course, the most important thing is for floating solar is water body, water quality, water flow, and the wave flow and the wave height. Why? Because this is we are going to determine the anchor and the mooring. Because as we know, anchoring and mooring is very costly, and it still need to comply certain of the standard. Maybe in the market, everybody will say the current floating solar, this is not much of on the standard safety standard, but if let's say you refer to the offshore, there is a lot of standard required by the anchoring and the mooring. That's why in this floating solar, we still need to use the offshore standard, because this is involve the wave and also the flow under the water and the wave height. Because if without this safety issue, there will be a fire. Okay, and this thing like it's already happened in Japan. Okay, for the floating solar, the location, as I say, when we select the site, the water body cannot be too steep and also cannot be too depth, because when you increase the depth, the mooring will become very costly, and also the anchoring also become very costly. That's why normally we will refer to the remote area, and there is not involved to the natural. Okay, and for floating solar, normally we will choose at the rural area. How about the weather climate condition? Okay, for the floating solar, normally we will choose the very calm water, which is the wave is not very high. If let's say we choose at the seaside, then our sea or the seawater, the wave become very high, and your anchoring cost will be become very high. And type of the water body, as I say, we cannot use a natural lake. Why? Because the natural lake, sometimes we don't know what is the problem of the soil condition, and also natural lake is require a lot of tourist business. So normally we would choose the lake which is low impact to the economy, and also the lake is a how to say is a minimum use by the business. Okay, then the water body characteristic, as you see, is must be a regular shape and widen opening towards south or north. Compared to the low preference is a narrow strip and the mountain, especially the Ganges. Okay, and underwater for the floating solar is might be shallow, depth, even terrain. Why you need an even terrain? Because this one will determine the anchoring cost. Because if let's say you choose too steep, your anchoring design will be different and become very costly. Sometimes it's maybe of course soft. Otherwise, your anchor I say that your anchor may not able to stand on the soft mud, then you require a pile. For this pile, costly, it's very costly, and it's not economical. Then how about the water condition? Of course, you need a fresh water. It's better to have a low, I'll say, pH 7, because it's too acidic or too alkaline also will affect your mooring, and this mooring is very costly. Salt water, dirty water, corrosive water, and water prone to the biofouling is low preference. Okay, its other condition is more to the existing electrical, especially when you the floating solar at the seaside, then your corrosion protection is become very high, or sometimes you involve the IP index, that means we may be use the very high years IP. Maybe go to the IP68 or IP69. This one also we're going to cause the EPC cost become very high. So that's why normally we will choose away from the seaside. And how about the ecology? Of course, when you go to the floating solar, you cannot, according to the World Bank standard, you cannot cover more than the 50% of the lake surface area. So that's why the floating solar, there's a lot of requirement. And if let's say your floating solar surface is covered more than the 50%, you will create the issue to the water species, especially low sunlight and also the low oxygen. So a lot of trouble to the lake. Okay, this is the standard used by the floating solar. Okay, before the floating solar, we talk about the standard of the use by the ground mounted. As we know, IEEE or AFRY or ISO is already established for the ground mounted. British standard also have SMIT, European standard, and the local standard. Okay, and how about the standard used for the floating solar? As we know, floating solar, a lot of people is not very familiar to the floating, especially the floater. Okay, but for us, we already done some research study. Actually, there is a standard. It's already applied to many floating projects. The most important thing is your HDPE material must be complied to the water standard. Other is a class 2. If let's say is less than this class 2, there is a cause harm to the water, then the water cannot be consumed. So as you can see that the standard code is already attached to this presentation slide, and this is a standard requirement by the World Bank. Not only for the plastics or PE mooring, and this HDPE for the structure holder. You have a positioning of the mooring standard, anchoring structure standard, and the marine works. This, and also together with the ISO standard, this is a highest priority by the World Bank. I mean, that means like all the developer or the bankers, right? They must be request the main contractor to comply the standard to make sure all the system is created. It would not harm to the environment. As you can see that there's a lot of I also talk about this plastic. So therefore, we cannot compromise the standard. If let's say we compromise on the standard, right, it will cause the fire. And this fire is already happening in Japan. Although Japan is, as we know, they are very good engineering, but somehow because of lack of the design, it will cause the fire also. Okay.
Sir Tan, do you mind to put your speaker closer? I believe there are some participants.
Okay, sure.
Be able to hear clearly.
Okay, sure. Okay. Beside this, the standard, right? Okay. The IP index, IEEE, IEC standard is mandatory for this floating solar. So it must be ensure that the floating solar system is safe to be used and can be last long for minimum for 20 years. Otherwise, it will be cause a lot of problem, especially the fire safety and also the animal visit to the system. Later on, I will show you the key issue is created by the market. No, not only floating solar, also for the ground mounted solar. Okay, this is okay. The next slide is a part of the one part of the local authority requirement. So besides we comply the international standard, we still need to comply to the local standard. This is in order to secure the development order. Okay, and the DC cable floating solar. Yeah, a lot of people, right? They are trying to use the those are non-marine cable. So this is not encouraged. So normally we will ask the clients to use the marine cable and also the marine connectors. Why we use this such of the high quality material? Because in Malaysia we have the safety issue, which is already accident. One of the guy is being killed because the cable is submerged to the water and leaks to the water. So that's why one of the staff is being killed by the water by this solar. As we know, the solar there is no switch. Then a lot of electricals leak to the water. Okay, so this is one of beside the cable. Floating solar have more issue than the ground mounted. Why? Because ground mounted, we have a lot of ample experience in the market. It's already stable, and compared to the floating solar, the most of the key issue is PID, and very luckily the IEEE have introduced a lot of PID mitigations activities, but come back to the commercial, a lot of people is not aware, and there is no publicity to the to the main con. That's why a lot of PID issues or corrosion issues is happening in the market. Not only in Malaysia happening, even those in China, in Thailand is also happening. That's why periodic maintenance is a mandatory and also required. Okay. Beside the module issue, the mechanical issues also a very big challenge, because as we know, for the floating solar, the water wave is not stable, is not calm, and there is it's a movement. So a lot of panels have been damaged. According my experience, floating solar normally will cause 50% of the damage to the panel, because there is some glass break or the heating module to the among each other, and also this hotspot, where the hotspot is caused by the dirt. So that's why it's increased mechanical stress. Okay. And others is okay, talking about the hotspot and the shadow. If let's say because the water floating solar, because the safety issue, and let's say you are lack for the maintenance, then you will create a hotspot to the PV module. The hotspot, it will increase the solar cells temperature, and it can be caused to a fire. So the maintenance activity, right, is might be carried out, but you still need to comply to the safety standard. That's why in the global, a lot of people lack of this awareness safety in floating solar compared to the ground mounted. Okay, for this earthing issue, as we know, a lot of people think that okay, the floating solar, you don't have a ground, but how to do the earthing? Okay, to do the earthing, we need to understand the water body and also the water characteristic together with the water temperature. As you can see that different water temperature, your coefficient of the resistivity is different. So we need to carry out those study to see that how to ensure the earthing can be achieved to the standard requirement. If let's say we don't have this earthing, what is the problem? Okay, you will cause the PID issue. Then your entire of the power plants will be degraded dramatically. You know, and Malaysia have this happen this issue. The power plant degrade 20% within 2 years. So that's why the earthing is very important, and we cannot compromise. How to do the earthing? Okay, there is a standard. So we not only to put the earthing cable into the water, we still need to pile inside the soil. Other to get the low resistivity. Otherwise, you cannot achieve some certain standard is required by the IEEE. So there is like you can see there from the table. This is which is researched by the Korea engineer and also published to the journal. And this is proven, and we have one of the experience in Singapore, which is normally to solve this issue, the inverter also playing the important, because you need a active grounding. Without the active grounding, that means you cannot understand what is the grounding happening inside the water. So there's this solution already in the market. It's just depending on how we're going to apply. Okay, so as a professional engineers or professional designers, we need to ensure that this active grounding must be implemented into the system. Okay, the next slide. You can see that a lot of large-scale solar, and this is happening in the Southeast Asia. A lot of solar power plant is lack of the technical study. You know, some of the plant is inside the flooding area. Some of the plant is no lack of maintenance, like grass cutting, and some of that is a lack of this environment protection. So you can see that without this safety or fulfill the IEEE standard, right? The plant cannot be sustained for a long period. So, and for my experience on that, right? Usually this kind of the plant performance is become very low. Why? Because first thing, you see, when the grass is grow too high, you will block the ventilation under the module. So that means you are going to increase the PV module loss. Okay. Then how about this flooding? As you can see that the flooding, if let's say a lot of water flow into the plant, you are going to damage the cable. So your cable will have electricity leak. So this is we are going to trip the plant. So that means your plant availability will become very low. Okay, and also you have a lot of area which is maybe the water flow inside the HDPE pipe or flow to the inverter. So also will damage the inverter also as well. So normally we advise the clients must when you do this plan, you must done a pre-feasibility study. If without the pre-feasibility study, that means you won't know what is the risk at the behind of the plan. I have experience in Malaysia. especially in Malaysia, most of the owner would like to skip about this site assessment, because they think that the site assessment you spend a lot of money and the project you see whether you can would receive the award from the Energy Commission or not. But when you come back to the financial modeling, if without this technical risk assessment study, that means your financial modeling is cannot be able to sustain. If let's say there is some damages because of flooding or because of the grass cutting or others, right? Then your financial modeling will be damaged. This is always happening in power plant, solar power plant, and some of that when they choose the land, they didn't perform the this pre-feasibility study. When come to the execution, then the financial modeling it will be out. Because why? Because the you need to comply the bank's requirement, which is you must able to check about hydrologist study, make sure that the plant it would not get into the flood, and also seismic. And because of these two key, it will how say will make the very big impact to the financial modeling, because you need to increase the height or increase the structure materials, so it will cause the impact to the financial model. Then after that, your project IRR or equity IRR become very low. Then your project not become a bankability. So this is a key issues. Then for the floating solar, as you can see that there's a biofouling, bird dropping, animal visits, and also the marinization. Okay, this is already happening not only in Malaysia, it's also happening in Singapore, in Thailand, Taiwan, Vietnam as well. Okay, so this is a big challenge, and there's some mitigation as long as you need to increase the maintenance activities. Otherwise, this one will cause impact. Maybe your energy generation will become very low. Okay, this is also another challenge. You have a mechanicals that those are insect, gone into the combiner box. Okay, you have a cable, the cable management, you see your cable and the connector is submerged to the water. That's why it's caused to danger to those workers who has not wearing this protection, electrical protections. So you will get the electrical shock, especially the DC compared to the AC. DC is much more dangerous compared to the AC, and also the IP rating for this junction box is also one of the important, because the junction box inside there's a diode, which is very sensitive to those inrush current. So the lining is one of the cost effect to this PV module to damage. Okay, this is one of the happenings in the last year. Floating solar, which is already happening, the accident during the typhoon. Okay, and this plant is commissioning and achieved the COD during the March 2019. It's happening in the Yamakura Dam. Okay, and this there's a accident in 8th of September 2019. Okay, if let's say you want to see this house back impact, you can see from the YouTube. Okay, to solve these problems, the EPCs come up the mitigation. They need to increase the mooring and the anchoring design to make sure that all the floater able to be whole and were not affected by this typhoon. Okay, and you can see that there's a very serious damage, and this is first floating solar damage in the world. So that's why we need to learn from this accident, and we need to overcome on this, and we cannot compromise those anything of this. As we know, in Malaysia, a lot of engineers, especially in solar, they have lack of this anchoring and mooring. Where to get this expertise? As you can see that in oil and gas, they have a lot of expertise in the mooring and anchoring. So to mitigate this anchoring and the mooring design issue, we can ask or ask the oil and gas consultant to help to do the design review on this. Otherwise, if let's say we done without the review, serious damage. Okay, summary. So as we understand that we need to hire a good engineering consulting. So make sure that you done a proper feasibility study and consider all the mitigate all risks. Okay, during the development stage. How about and also when you select the EPC, you make sure that your EPC have extreme experience in the floating solar. Not only in the floating solar, even those in the ground mounted solar, you also need a very high experience. Why? Because in Malaysia, most of the Malaysian land is not flat land. As you can see, Malaysia topo map, right? Malaysia, you can see most of more than 70% is a hill. So to install the solar panel at the hilltop or any a land with a different elevation, you need a proper engineering study. It's not means that you putting up the structure, you get the structured design with the with the one wind velocity calculation. That's wrong, because what we see that I also have a experience in Thailand. When the EPC don't have an experience in the calculation for the mounting structure, for the hilltop and the flatland, there is damage and cause the structure broken during the high, very strong wind. So what happening? And this will impact the plant. They have to shut down one of the zone area because you need to do some repair work and also to do some mitigation and how to protect these issues. Okay, so and beside the engineering experience, the high sensitivity to the environmental and the social consideration is very important, because when you're doing the project, you cannot have environment the environment damage. Why? Because when you have this environment damage, that means, let's say for example, you have a soil flow out from your land. That means you were going to create the environment issue. You may be caused the neighbor of land into the flood. So this is why it's very important. I have an experience in Johor, in Malaysia, Johor, southern of Malaysia. One of the because the land is choosing is far away from this main road. So what happening? This the authority is not easy to approve the extra land to create the road. And because cannot get the road, that means your construction, your mobilization is not able to land it to the actual proposed site. So that's why the environmental study is important. Make sure that you will not cause to the other trouble to the neighbor. Crucial engineering design shall not compromise the standard and the country acts. If let's say you compromise, you will not only the developer will cause the issue, even those the professional engineers they will be charged to the court because it's not maybe you not oversee the properly of the design, or maybe you cause this owner have a business loss. So for my advice, I would like to advise professional engineers, make sure that if let's say you are not in this area, please consult with the proper guide and to get a proper as a consultation. If not, you will getting very big trouble. Not only for the engineering, also trouble for the financial modeling. Okay, that's all. Okay, thank you for the audience. Okay, so any question, please let me know.
So I open the floor to anyone who has questions. Let me start off. I have some questions. The first question would be, what are the environmental impacts of this floating solar plant that you can share with us?
Okay, you can see that normally the floating solar, the big issue is the floater, because the floater chemical reaction is degrade. Because when your floater is touched to the oxygen, it will oxidize the material. So you must make sure that you're able to achieve, I'll say the materials as safety. You must able to achieve the, the world's health organization set the standard. That means you must able to achieve the water, the material achieve the water safety at the class 2. This is a minimum requirement. Otherwise, you will cause the fire and you will pollute the water. This is this is already happening in Malaysia. It's not the cause of fire. It's federal government put up the question: is that the material will not cause to the fire and polluted the water or not? Until now, there is nobody able to answer this question, because as we know, floating solar is PPA is more than 20 years. Then you cannot change the material within the 20 years. So how to sustain? When you want to sustain the material, sometimes you may use the very toxic chemical. So how to ensure that the toxic will not leak to the water? So until now, this global is there's no proper question on that, because you need to comply to the water safety, and you also need to comply the PPA. Okay, and also the liability of the structure itself.
Okay. Okay, there's another question. Just now during your presentation, you mentioned about the incident happening in Japan. Can you share more details? Where and when?
Okay, as you can see from the from my slide, let me come back to the slide. Okay, you see, I already put up this happening is in Yamakura Dam, which is in Ichihara City, and this project is the biggest floating solar in Japan, and the accident is happening is 8th of September 2019, which is last year, and during that time there is caused by the typhoon Faisal. So this is become a very global news, and Malaysia during that time, there's two solar floating solar project is on hold because this news the government decide to ask the developer to ensure that how they can protect this fire and cause to the water pollutions. You know, until now there is no how to say solution, and the project is on hold until the owner can come up the solutions how to they can mitigate these issues.
Okay, thank you. And there's another one more question. Well, I have actually read a case study from an article that says a 10 megawatt site at the Ramgiri in India has been considered for installation of floating solar plant. But I think you also mentioned compared to the ground-mounted, floating solar plants are expensive to set up, as the cost of the floaters constitute about 50% of the total project cost. So what is the feasibility? How big of the size of this floating solar plant would you propose?
Okay, this one is depending of the available of the lake. As I mentioned just now, we cannot cover the entire of the lake more than the 50%. If let's say you cover more than the 50%, that means you were going to disturb the ecology inside the water. Maybe the fish will die because the fish die because you don't have enough of the sunlight go through the water, and there is no photosynthesis inside the water. That means the less oxygen, then your water quality will change to become the acidic, and at the end you will cause a lot of this aquaculture, a lot of fish or other bacteria that. That's why in the global, right, normally we design the floating solar, the ratio of the surface must less than the 30%.
Okay, so in this case, for the context of Malaysia, would you then propose floating solar or ground-mounted solar power plant?
Okay, because Malaysia, everybody is talking about the competitive tariff, so there's not much of the floating solar, unless you want to have do some social activities. You want to create the academic study or research study, so you create a small floating solar. But normally, a lot of people go to ground mounted because it's easy to control and also faster to install compared to this floating solar. And as I mentioned to you all just now, the floating solar you require a federal approval. Why? Because most of the dam in Malaysia, okay, is gazetted inside the act. So to remove the dam from the act, right, is very, very tough. You must get the not only the cabinet approval, you must paper to the parliament. So this process is take a very, very long time. So normally in Malaysia, most of the investors they are trying to avoid on the floating solar, and they select the ground mounted. If they say there is no land, not enough land for them, they select the lake. The lakes must be less useful. That means it's no any create for the tourism, so you can use the lake. But come back to the design as the question before. You must make sure that your design cannot be more than the 50%. Otherwise, you still create a lot of the ecology issues to the lake. Okay.
Okay. There's one more question from Bunhan, the question is why PID exists when there is no earthing? By right, when grounding, it creates large potential and therefore PID happens. Like double glass module, no need grounding and therefore no PID. So for floating solar, is there other reason that is causing it?
Okay, as you know, the floating solar, of course, you put the double glasses floating solar, you not require the PID, but then you come back to the large scale, very large scale. Okay, when you have a very strong wave, you know, that means your module damage is become very high. As I just now I mentioned, I have one project. Because they installed this a double glass around 50 throughout the 5 years, around 50% of the PV module have to change because you know the module among the module is heating up because the wave. And the secondly is because the glass. Okay, the glass when you have a too big size of the how to say PV module. Okay, your glass strength it become very low, and especially when you force you see the wavelength of the water is up and down. How are you going to ensure that your PV module will not I say the surface will not sagging? If let's say there's a sagging, that means there's a high possibility of your solar cell is become cracked. Unless you are using the say one of the material of which is created by the sun power. Okay, the solar cell is not easy to break. If let's say you choose the normal commercial, the solar cell, when you have a little bit of vibration, the solar cell will be a crack. So the cracking, the micro crack or the other cracks is a very how to say is questions to the floating solar whether this water wave is become calm or not calm. If they say the calm, then you can use the double glass. If they say the water wave is not very calm, so you must use the conventional type of the PV module. Yeah, that's all.
Okay. Munhan has also mentioned, he said, I mean, why frame one if without grounding will still cause PID? I know that it is important to have grounding, but the slides mention no grounding cause PID.
As I say, it's a double glass. Usually, there's no PID impact because your electron are leaked to this PV the frame. As you can see that when you attach with this PV module, there's at night your some of the electricity will flow back to the PV module. So to avoid this electricity, the night flow electricity night flow back to the PV module, you need to install let's say active grounding. If let's say you install the active grounding, so then your PV module for the double glass, you no need to have this earthing, and also your PID will not appear for the double glass. So the active grounding still need to be installed inside the inverter. If let's say without the install the active grounding, right, nobody can ensure that the double glass will not cause the PID, because until now that in the world, when you talk about this commercial, right, you just want to make sure that everything must be safe and the groundings must be not only hanging at the middle of the water, it must be powered inside the water body. To power inside the water body, it becomes very costly also. And you also know that when the copper also will cause a corrosion, then how many times you're going to ensure that your copper resistance can be achieved according the IEEE standard requirement. Okay, So if let's say you want to save about this cost, right? Then that means you are going to carry the future risk. Maybe after 10 years or maybe after 5 years, nobody will know. Okay, so that's why as a lender technical advisor, normally we will recommend the owner to install whether it's happening or not happening. You still need to avoid those risks. It's just like, for example, for the lightning. Everybody also don't like the lightning pole, but you still need to install. Why? Because you need to protect the future damage, same as a PID. So if let's say without this monitor I say earthing the system, right? That means you will cause the module to have a PID issue. Okay.
Okay, is there any other questions from the floor? No? Okay, thank you very much, Mr. Tan, for the presentation. Would you be able to share us your presentation slides so that we can share with the participants? Okay, thank you very much. And thank you so much for the participants for joining today's webinar. And I hope we will see soon for the next events coming up. Do feel free to check our events in our Facebook, IEEE Malaysia. Thank you.
Okay, thank you.